Use logarithmic differentiation to find the derivative of this function y equals x squared plus 1 raised to x. This is a function raised to function, so there is no shortcut rule. Okay, so what we do first, we rewrite this function as in a nicer way so that we can find the derivative. For recall from the algebra, when we have something, let's say p, that is same as e raised to ln p. E and natural log, their actions cancel, just p survives. So this function is equal to e raised to natural log of the whole thing, x squared plus 1 raised to x. In the next step, we know another property of natural log of a raised to b, then this b factors out, so b natural log of a. So in the exponent we have natural log of quantity x squared plus 1 raised to x. Let's factor this to the front. Okay, this to the front, then we get e raised to ex natural log of x squared plus 1. Okay, we are just rewriting the function. Now this looks like e raised to something, a function of x, and we know from the chain rule, when we have e raised to something, let's say u, and find the derivative, outside function is e to the something, inside is u, so derivative of eu is just itself times derivative of inner function u. So the whole thing here is like u, e raised to u, then or now the derivative is e to the u is itself ex natural log of x squared plus 1 times derivative of inner function, that's this top part, x times natural log of x squared plus 1. So we are done with this factor. So prime means we need to find the derivative here. This is e raised to x natural log of x squared plus 1 times, here we got a product of two functions, x and natural log of x squared plus 1. It's like u times v, and we know the product rule, u times v, that's u prime v plus v prime u. Okay, this is u, this is v. So using the product rule, derivative of first factor x is 1 times natural log of x squared plus 1 plus derivative of second factor is a natural log of something, x squared plus 1. Another chain rule, we know that natural log of something, and when we find the derivative by chain rule, natural log of something is 1 over that u times derivative of u. If this u or just x, then derivative of natural log of x is 1 over x times x prime means derivative of x, which is 1. So it's like that, natural log of something, so 1 over x squared plus 1 times derivative of inner function, which is x squared plus 1. So derivative of x squared is 2x plus 0, just 2x. Okay, that's the derivative of second factor times, leave the first factor alone, just x. Okay, we were using the product rule, and this is it. You may leave here, or if you want to simplify, in fact this e raised to x natural log of x squared plus 1, if you go back, then you get the original function. So you may leave this, or if you move x to the top, e and natural log cancel, so x squared plus 1 raised to x. We wrote in this way just to make this formula work. Okay, times inside 1 times natural log of x squared plus 1 itself plus do not cancel anything, 2x x 2x squared on the top all over x squared plus 1 final.